All right, so let's talk about .NET Reflector, although I'm actually going to use ILSpy, but the point here is reverse engineering .NET apps. I made a sample app, which is, of course, the same one you just saw us make in the previous project to get started. So I downloaded it already on this machine. In the Downloads folder, there is ED331. And if I sort by name, and I somehow get it to stop grouping things. Let's see, I did find it finally. Group by none. There we go. Now objects with the same name are together. And here's the original app, ED331-1. This one I don't need. I would delete it if I could figure it. There we are, good. All right, so ED331-1, if you run it, you have to click more info and run anyway. And now it's just another version of what you just saw. There's a place to put a password, and if you put in the wrong password, it says fail. All right, that's the simple game we have here. Now, the interesting thing is we want to analyze this. Now, you can use .NET Reflector, but it's a proprietary product, and if you install it, you can only use it for some period of time, like 15 days. And I've already demonstrated this in the previous class, so I've used up .NET Reflector, but I tried it earlier today, and by the way, you can do all this in an ARM machine, that's what I'm doing it, or an Intel machine. You can use ILSpy just as well, and ILSpy is a free app that also lets you look inside .NET apps. So I'm going to use that because my Reflector trial has ended, and removing it and reinstalling it did not give me another trial. And it's very similar to it in that everything you add gets added here. I'm going to remove this old one. Just like the other app, there's several things that are parts of Windows that automatically appear here. And to analyze a new app, you just open it with File, Open, go into Downloads, and there it is, ED331-1. And now it appears here, and just like Java, it's a container with a lot of objects inside it. So you go, I think, to the Form app here and expand that, and then Form 1. And in here you find things like the button and the text box and so on. And in this case, it's the button. The button is just a button, but the button click is an event, and that's where the code lives. So here's the button click, and here's the code. And this is the intermediate language code. And by the way, you can see it in various ways. The default is to show you the intermediate language. This is the compiled language, but maybe I don't remember what the default is, but you can also see it in C#. And this is a thing about .NET that is great for reverse engineers. The same thing's true of Java. You have the source code of every app, and developers clearly do not understand this. So I can just read this source code, and I can totally see what's going on. If the text box contains top secret, you win. Otherwise, you fail. So that's pretty awesome. So I can read it to find things. I can also modify it, and that's what we're going to do here. If you view the intermediate language, you'll see this raw Microsoft intermediate language. And one thing I just saw today, which is pretty cool, is it has IL with C#. So now it adds C# in comments. So this is the if that checks if the text box is top secret. And as you can see, it takes 6 intermediate language commands to do that. Here's the next one that will show the win function. It takes a bunch of commands to do that. So you can totally see how it works. All right, so now let me go back to my instructions. All right, and the point here is I'm going to see the raw hex for these instructions. That's my goal. Now here, I should see this, the part that gets up to win. It has a branch false before loading the string win. And there's a branch false, and there's the win. See, this is very much like the thing we did in Ollie a while ago. We had a game, and we went and modified the game so we'd win. So notice, it goes through some kind of work here to compare the string, and here it does a branch on false to go down somewhere and tell you you lost, but it will, if it's true, you'll win. So I'm going to take this branch false command and change it to a branch to command, and then I will always win with the wrong password. That's all I need to do. Now, it turns out this product does not show you the raw hex values, but they're known. You can find them on Wikipedia. If you just go here, Common Internet Language is here, And so the command I'm looking for is branch false S. So I can just search for it, brfalse.s. Okay, there it is, with int 8 target, and that's 2C. And if I wanted to do branch true S instead, that looks like, I thought it was 2D. It is 2D. This is branch if inst. I don't know why they're showing inst here instead of true, but anyway, let me go to my instructions and see if it's more clear there. 2C, the XML code for branch true is 2D, which I used to say here. Apparently they've changed the description of it. Let's try searching for branch true. That's how I found it before. Oh, there it is. Branch true S alias for branch true is this, which is 2D. So all I need to do is change a 2C to a 2D, and the game will go from a hard game to an easy game. All right. And by getting a few more commands around it, I was able to find the pattern. And here you are. Here's the commands before the branch false is 0 in is 06, 2C, an unknown number, and then a 72 with 4 numbers after it. So we can just modify it with HXD. So I'm done with this ILSpy, and here's the ed331.exe, which is there. I can open this with HXD. ed331, okay. All right, and now I can do a search for these values and find all. That's the easiest way to do it. Search, find, hex values, those 3 hex values, and search all. And there are 3 places where it occurs. And what I need is to have, after the 2C, 1 byte and then a 72. And there's only one place where that occurs. Here I have 2 bytes and a 72, but I want the 1 byte and a 72. So I go there, and now I change that 2C to a 2D. And save this modified file. I'm going to call it 331 hacked. And that's it. Now I have created, whoa, something weird is happening. It's changed the view to something stupid. All right. There are people with mouse gestures, and they constantly fool me because I'm clumsy. All right, ed331 hacked. Run this one. Okay, and now I put in the wrong password, and I win. So that's what I wanted to show you. And there are a couple of challenges here where you get to hack various products. So here's one. You'll just need to get the CRC32 of that one modified. And then there's another one where you got to find the flag, and some more where you have to hack into these and find the flag. And you'll see it's really very easy, much easier than using OllyDebug, and hacking native code is hacking .NET code. All right, that's what I wanted to show you. Let me